this and Android. Yep. So there are 3 homeworks due tonight, 2.3, 2.4, and 2.5. So Sina, do you have any questions on this homework?
For 2.3, I have 10, 17, 18, and 23.
17, 18, and 23. Okay.
Yep. And then
2.4.
2.4, I only have 13, 14, and 17.
And 2.5.
2.5, I have what is it? 4, 5, or 6. You can do either one of those. And then 17 and 19.
Okay, good. All right. So let's take a look at 2.3. So I don't know where the rest of the class, so we'll see. So 2.3, question 10. I can read. So question 10, you need to factor it. I think we did this before on your previous one. Do you know how to factor a polynomial, a quadratic?
What is it? Isn't it what is it, AC method?
Yes, you have to use AC method. So what you do here is, for example, like this is a question, this is the same thing as question 10 that you asked. So if you have this, you just need to set this equals to 0 and you have to solve it. This is number 10. This is question 10. I just do another one. So 7x squared plus 26x minus 8. So you have to use the AC method here. Yep. So AC in this case is negative 56. And then you have to figure out what times what is negative 56. When you add them, is 26. Sinu, you okay with that one?
Oh wait, yeah, I'm okay. I did the math wrong on my. Okay, never mind. Yeah, I'm okay.
So yeah, we did this already, so that's why I do not want to do it again. And this is mostly on factoring. So question 10 is mostly on factoring. 17. Yep, we'll do 17. So 17 and 18 is the same. So I will just do one of this.
Okay.
They're the same. So I'm going to do 18 because 18 looks a bit more difficult than 17. So in order for us to find the average rate, so this 2 question is asking us to find the average rate. The formula for average rate, you know what's the formula for this one?
No.
It's like slope. You remember slope? y2 minus y1
equal
over by
x2 over x1.
x2 over x1. But instead of y2 and y1, we don't use y2 and y1 because it's in a function mode. So you will do the f of x2 minus f of x1, which is the same thing as y2 minus y1. So what you need to do first is to find the f of x2. And in question number 18, x2 is 7. So you just need to find what is f7 is. So you plug 7 into this function, into your x. So negative 3, 7 to the power of 3, plus 4, 7 squared, plus 7. So I just do the f of x2 first. And then use your calculator to figure out what is this number is. This is a big number actually. So negative 3, 7 to the power of 3, plus 4 times 7 squared, plus 7. Oops. And that will give me Something wrong. I need to. Negative 826 is a big number. So this is how you find the f of x2. And then next you find f of x1. And given us in this case, x1 is 3. So you just need to find f of 3. So you replace all the x to become 3. And you figure out what this number is. So you place all your x here with 3. So so make sure you have a calculator here. So you just redo this question again and just change it to 3. All the 7 become 3. So most of this calculator here. This is negative 42. So what you do now is you plug everything back into this formula. So f of x2 is negative 826 minus f of x1, which is negative 42, over by x2. x2 in this case is 7, minus by x1, which is 3. And then I think you know how to do the rest of it. And whatever you get here is your answer.
Okay.
So the formula is, this is the formula. And 17 and 18 is the same. We use the same formula. You all right? Yep. Make sure you, this formula is important. Yep, 23, this is pretty hard. So we will look at 23 here. So we need this. So 23 is giving us this graph. So they're asking us to find what is the domain and range of this function. So in order for us to find the domain is the x value. So what x values can you have in this function? Where it starts and where does it ends?
It starts at -4.
And ends at?
It ends at 5.
So -4 is colored, is closed. So you have to use a bracket. And 5 is an open. So you have to use a parenthesis. You got it?
Yep.
Range is the y value. So what is the lowest minimum and what is the maximum for the range in this case?
The lowest is 0.
0.
The highest is 9.
9. And 0, is that close? Do we touch or not touch 0?
We touch 0. So
we have to use a bracket since we touch it. And 9, now 9 is special because you got open, you got open circle here, and then this one touch, right? Mm-hmm. So for you guys who doesn't know which one you pick, you always pick the one that is touch. So the bracket in this case has a more seniority or has more choice. You have more power to do it. So you always use the one that is been touched instead of the one that's open. You go okay there?
Yep.
0, you know what's the meaning of the word finding the zeros?
No.
So 0 is the meaning of x-intercept. So can you tell me where is your x-intercept in this? I mean the graph that crossed at x-intercept.
Is it the 3?
It's a coordinates. So this one. So what is the coordinates of this point? See, it's given us coordinates.
3 for the x and then 0 for the y.
Yep. So so every time when you do your homework, if they write something like this, means they want it in coordinates form. Okay. Increasing, decreasing, and constant. So increase means the graph goes up, decrease means the graph goes down, and the constant means the graph goes flat. So if you look at this graph, the first thing is they are increasing. So if you read left to right, this is going up. So it increased, and then what happens? It will
decrease,
decrease, and then after that, it will increase back. So that is no constant here. So DNE for constant because there's no flat line. So increasing, we got two. We got this one and this one, the first line and the third line. So we're always looking at the domain of the for this case, and you always use parentheses, no matter if you have a closed circle or open circle or touch or no touch. The reason why you use parentheses is because when you increase or decrease, you do not use, it doesn't really start at that point. It just go from that point onwards. So increasing in this case, if you look at the domain, it goes up from -4. And where did it go up to?
It goes up to 9.
No, again, it's a domain, not your range. And what is a domain for this? It's your X value, not your Y value.
Oh, 0.
0. So this one is go from -4 to 0. And then you have to use the union. So you go under set and you use the union here because you have to go from this to that. So what is the domain for this increasing piece?
3 to 5.
3 to 5, yes. Decreasing is just from here to here, right? This is a decrease. So what is the domain for this case?
Wait, hold up. Where do you find the union sign?
Right under set.
Okay.
And then the U symbol here. And for decreasing, what you have is from 0 to 3. So this is the decreasing sign in this case. Okay. All right.
Yep.
Relative maximum and relative minimum. The relative maximum and relative minimum is your turning point. So if your graph have a turning point, if it's going up, if you have this, then this is a relative minimum. And then if you have this is a relative the other way around. This is maximum. And this is the minimum. So if you look, and it has to be in coordinates. If you look at this again, they give you X, Y, means it's coordinates. So where is the minimum turning point do we have in this graph?
What is it? 0. What is it? 3, 0?
Right here, right?
Yep.
This is your minimum turning point. So what is the coordinates of this?
3, 0.
And maximum turning point is this one.
0, 9.
And lastly is even, odd, or neither. So in order for us to find out if you have even means that it is symmetrical with the y-axis. So if you have a parabola, this is even because it is symmetrical to the y-axis. Okay, odd is symmetrical with the origin. So what is meaning of symmetrical with the origin is here. So when you have a graph that is symmetrical with the origin, it means that you will do, if you perform reflections on X and the reflections on the Y-axis, you will get back the same graph. So what happens is if you take this line, if you reflect this on the Y-axis, it will look something like this. Okay, so this will flip over there and this will go over there. And then if you take this red line and reflect it on the X-axis, this line will go back to the same. So this is what it means by odd or origin, and even means it's on the Y-axis. Okay. So if you look at this graph, you think this is some even, which is symmetry with the Y-axis. That means that if you fold, let's say this is a piece of paper, if you fold right on the Y-axis, they will, like coincide. They will kind of like the same, like reflections. You think this will be symmetry to the Y-axis for this graph? The answer is no, because when you flip this, in order for it to symmetric to the y-axis, it should look something like this. So when you flip on here, when you you fold on here, they are symmetrical, but this is not even. So odd. Since this graph does not, if you have odd, usually it goes down to the, it has a negative part of it. So unfortunately, this graph doesn't have a negative part on it. So this graph is neither. Okay. So make sure you know how to do these kind of questions, because it will I will ask you these kind of questions in your test. Okay, like all this domain range, zeros, increasing, decreasing, relative, maximum, minimum, and even odd function. You all right?
Yep.
Next we have is question the next section. 2.4. So in 2.4, the mostly about 2.4 we have to think about here is what your graph looks like. Okay. So number 13 and number 14. This is yep, kind of figure out what's going on here. So so let's take a look at number 13 on here. This is a bit tough. This is what we call as a greatest integer. And what is greatest integer in this case? It is a step graph, or what we call it as a staircase. So what happened is that at 0, it will be at 0. And then at 1, it will goes up to 1. And then at 2, it will step up at 2. So it's like a staircase. And then at 3, it will go like this. And this, don't forget, this is closed and this is open, and then so on. Okay, so this is x. So what we have in this case is g of x, x minus 3. Now you can always use substitution. Okay, you can plug in numbers. And if you look at this, we can plug in 0. So when you plug in x to become 0, you get 0 minus 3. Do you know what 0 minus 3 is?
-3.
So y in this case will be -3. So at 0, this will be at -3. Now, if you put, so this one will be actually looks, is that right? X. Yep. When x is 0, y is -3. Yep. When you put x is 1, this will become 1. So 1 minus 3 is a -2, right?
Yep.
So at 1, this will be at -2. So don't forget, this one is a step function. So this will go all the way like this, and then they have an open circle. And then you don't need to figure out anymore because this is a step function. This is 2, and then you go all the way to this. And then at -1, it will go from 2 to 3. So it's going to look very similar to this one, but it is going downwards to -3 here. So how do we, and then you go on till 4, which is here to here. How do we know that we start from 0 to 4? Is because your graph, if you look at your graph here, you start at x is 0 and it ends at 4. So how do we graph these step functions over here is you have to pick the line segment. You see this line segment?
Yep.
So it's no arrow. So what you do here is you start at -3 and then you go to 4. Now this one, it used to be, if you look at the graph, it used to be a close and then open circle. So what you need to do here is you click on this graph and then you click on this circle. So this will be an open circle. And then the next one, you just need to continue drawing it. So you click this again, and then you go from 2, -2 to 2, and then you click on this point again, and then here, and then you change it to open circle. And then you do the same thing. and then click on it, and then do the same thing. So it's kind of like a staircase. Then click on it. So this is what your graph will looks like. So this is it goes from -3, and then it slowly goes up. You all right there, Sinu?
Yeah.
So this is called the step function in this case. Next is piecewise function. So this is a piecewise function. So you do not need to worry much about this greatest integer, because I won't ask you in your test, but you will see this again in your calculus 1 class. But this is the one that we will talk more, which is what we call as a piecewise function here. So when you have a piecewise function, you have to draw two graphs. If you have two equations over here, you have to draw two graphs. The one at the end here with the x is less than equals to -6, that is your restriction of your domain. It means that that is where your graph ends or the graph starts. So so I will show you what it looks like. So first thing first is we're gonna draw this x plus 7 first. So x plus 7, the graph, this one is easy to graph because is you know your m and your b. So what is your slope in this case?
1.
1. And your y-intercept?
7.
7. So this 0, 7. So we start at 7, right? And then the 1/1 means you go up 1/1, right?
Yep.
Up 1/1. So this is your graph of y equals to x plus 7. But it has a domain restriction. What is this domain restriction says? That it says that at -6, you only can draw this graph when this number is less than -6. So what happened is at -6 and below, you take it. Anything that is above -6, you have to erase it off. So your graph will be just this one. You okay there?
Yep.
So this is how we draw a piecewise. This is called piecewise function. So this graph only take a piece from x that is less than equal to 6. Now we do the same thing on this graph. Y equals to 1/2 x minus 5. This one we know the y-intercept is at -5. And your slope is 1/2. So 1, then you go over 2, right? 1/2. So this is your graph of y equals to 1/2 x minus 5. Let me draw longer here. But this graph only takes from where?
From -6 to and less, or from
More.
-more.
Greater, right? So more. So, but this is no equal sign. So you notice that when I draw this, there is an open circle, it's a closed circle here. It's because there is an equal sign for this. This one doesn't have a no equal sign. So we're gonna have so at -6, this would be an open circle. And we will only take all the way from here. So we will erase this fellow. So this is your piecewise function. So we need to find some coordinates because in your graph, you usually need to find some coordinates. So how do you figure out your coordinates? For the first one is this 6. So what you put here is you substitute -6 in here. And what happens when you substitute -6 inside here? You will get
1.
1. So this coordinates is -6, 1. And as you know that when you draw a line, you need 2 points. So you need one, you got 1 point. So the second point has to be on here. So when you plug in for another x, you have to plug in like -7 or -8 or -9. You cannot use any number from here. So we will use -7. And when you plug in -7 here, you get what? You will get
0.
0. So this is for the orange line. Then for the blue line, you also use this, and this time you also have to plug in -6 in here. So when you plug in -6 in here into your x, you will get half times -6 is -3 minus 5. So when you plug -6 here, you get -8. So this coordinates is -6, -8. And it has to be an open circle. The reason why is because there's no equal sign. And because of this domain restriction, you cannot use -7 or -8 or -9. You have to use any number that is greater than -6. I will use 0 because that's the easiest point. If you plug 0 in here, we know your answer is -5, which is right this point. So now now how do we graph this? Is based on this coordinate points for the first line and this coordinate point for the second line. So let's draw it here. So how do we draw this graph? Is now because this is a ray, we call this ray. So you have to use the second one because they're not a line segment or a line. So you have to do ray. So for this one, we will draw from -6, 1. So -6, 1, which is this one. And then the next point is -7, 0, which is this one. So this is the graph for the orange one. You got me, Sinu?
Yep.
And they all are closed circle because there is an equal sign here. So they all has to be closed. And then now we draw the other, the blue line. The blue line we have, so you have to select this again and select array. And then you have to put in -6, -8. So -6, -8 is right here. And then 0, -5, which is right here. So this is the blue line. But this blue line, the ray for this one, this has to be open circle. So you click on it and then you select open circle. Yep, there you go. So make sure you have an open circle on this one. The reason why is because there's no equal sign. And then that's how we draw this one. So it takes more time to draw this in your homework than to do it on your paper. So in your task, yeah, this is in your task. Just draw it as I will give you a graph paper like this. You just draw it by hand. You all right?
Yep.
Yep. This is what we call as piecewise function. Last one is 17. So this is also asking us the same type as what we have done on the previous section on 2.3 and number 23. So again, this line goes to infinity. So what is your domain in this case? Again, your x value is your domain. What x values can you have?
-2 to 2.
No, this one keeps on going.
Oh, so infinity, -infinity to infinity?
Yep. So if you use infinities, you have to use parentheses. For infinity, you have to go under symbol because your keyboard doesn't have a infinity symbol. So infinity to infinity. Yep. Or another meaning means it's all real numbers. Okay. So this is your domain. Range is your y value. So what is the smallest and the highest y value can you have? The smallest y value in this case is
0.
0, and the highest is
infinity.
So do we include or not include 0?
Include.
We include 0, so that's why you use a bracket. And infinity is always use parentheses. So make sure you know that all infinity use parentheses. Can you tell me what is your x-intercept in this graph, on your graph? What's the coordinates of your x-intercept? Which is right here, right? So your intercept and the x, 0, 0. And what is the coordinates of your y-intercept? Oh, so in here, because it intercept here on x and y. So what is the y-intercept in this case? Also 0, 0. Now we do the increasing, decreasing, and constant. So do not look at the arrows because a lot of students look at the arrows or they point up, so they all go increasing. So no, read your graph left to right. So when you read this graph from left to right, this graph is actually going what first?
Decreasing.
And then?
Increasing.
So there is no constant in this case. So we put no constant. So you say it starts from decreasing. So what is the domain or the x value when it decreases?
-2. Or
again, this one
negative?
goes all the way.
So negative infinity
To
infinity.
no,
Zero.
it stops over here, right? When you go up. So it go from negative infinity to what?
To 0.
To 0, yep. And again, for increasing and decreasing, you always use parentheses, no matter what it is. And increasing?
0 to infinity.
Okay. So this is your is this even, odd, or neither? So as I mentioned early on, even means it's symmetrical on the y-axis, odd means it's symmetrical on the origin. So is this symmetrical with the y-axis?
Yeah.
Yes, because when you fold this, if you have a paper you fold right here, these two will be like, they will coincide. So so in this case, it is symmetrical. It's even, so it's symmetrical to the y-axis. You okay with this one?
What is it? So my question looks a bit different. So there's a constant on mine. So does that change the x-intercept or for
like what do you have? X squared?
I have x to the 6th power.
Yeah, it's not. It's the same.
It's the same. Okay.
So if you have x squared, x4, x6 even power, what happened is if you have, as you mentioned just now, if you have, so x squared will look something like this. So when you increase it to x4 is going to be flatter down here. So your graph will be flatter. X6 is even flatter. So you have this, and it's even flatter. So this is x6. So so you still have the same property as this, all of them. So no matter if as long as your power is even.
So there is no constant?
You mean this one? Yeah, there's no constant in this case.
Okay, so even if x is to the power of 6, there's no constant.
No constant. This is if you zoom right in here, it will still look something like this. If you zoom in. So it's not flat, it's still go all the way down and then go all the way up.
Okay.
Same thing happens to this one. This is x cubed. So when you have x 3, 5 odd function, 3, 5, 6, 3, 5, 7, that is still no constant here. So what about this one? What is the domain for the cube of 5th, any odd power here?
Would it be
again, this goes all the way to infinities.
Yep.
This one goes all the way down and up.
So negative infinity and infinity.
Yep, this one goes to negative infinity to infinity. Yep. How about your range in this case? What is the y value can you have?
Is it still negative infinity to infinity?
Yep. So this is a property of cube, or odd function. So I just want to point out to you that if you have x cubed, x5, x7, your domain and range is always all real numbers. What is your x and y intercept for this case?
0, 0 for both.
Yep, because is this graph increasing, decreasing, or constant if you read left to right?
It's increasing and then increasing again.
So it's keep on increasing, right?
Yep.
So it's increasing the whole time from where to where?
From negative infinity to 0 and then 0 to infinity.
So in another word, Sinu, that means the whole line. So again, when you zoom this in to here, if you zoom in, it will still keep on what going in up. So that's why you increase from negative infinity to infinity. But do this graph ever decreasing?
No.
No. Constant?
No.
No. And this graph is even, odd, or neither?
Even.
You can tell by looking at your powers.
Oh, odd.
This is odd. And odd is always origin symmetry. So make sure you know this, because this is a basic graph here. So you have to know all this is x squared has this property and x cubed, and then x4 have same back with x squared. So again, 2, 4, 6, 8 even powers, and then odd 3, 5, 7 will have these properties. You okay?
Yep.
And the next one we're going to talk about here is 2.5. So we'll do either 4, 5, or 6. Yep. So first thing, like this is already give you x squared. So there are some transformation that you need to know. Do you know your transformation?
What is it? I got kind of confused by looking at them.
Okay, good. So in transformation, I'm going to show it to you what it looks like. So when you do transformation, I have some. If you have plus h, means you go up h unit. Sorry, let's do k. I don't want h. I want to use k. If you have a plus k, you will go up k units. For example, f of x equals to x squared plus 3. Or f of x equals to square of x plus 4. So this means that you take the x squared, which is the parabola, the one that you just did just now, and you move it up 3. Okay. And same thing with this. Do you know what is a square root of graph looks like?
Is it the one with like a, what is it? A right angle, basically?
We don't have a graph of right angle. So you learn this in 2.4. That's why this is called basic graph. Where was it? And it's not in here. So x square root looks something like this. This is a square root graph.
Okay.
So square root graph will look something like this. So I recommend you go to 2.4. That is in your textbook. There should be a whole graphing tools that you need to know them very well. So if you have a minus k, means you go down k unit. For example, is x squared minus 3 or square root of x minus 4. So watch carefully your numbers. So this is going up and down. If you have the number inside this, you go left and right, but your orders is been switched. So when you have a negative h, you go to the right h unit. So a lot of people think h negative means you go left, like coordinates. Negative means you go left, but for inside, you move right. So for example is x minus 3 squared or square root of x minus 4. Do you see the difference between the one I've given here and the orange one, the black and the orange one?
Yep, I can see it.
So make sure you understand that if the number is inside the square root or inside the square, you're moving left or right. But if your number is outside, you go up and down.
Okay.
And it changed, the left and right, it changed. So if you have plus h, you move left. So example would be x plus 3 squared or square root of x plus 4. So for example is if I want you to graph this, so we know the graph is this is the x squared. And then x plus 3 squared means you go to the left 3. So this used to be at 0, 0. Now it will be at negative 3, 0. So this is your graph now. You go 3 to your left.
So then, even if it says like plus 3, you still have to go to the left.
Yeah, that means you translate. You take all this graph and move it 3 to your left.
Okay.
And for this,
because I thought that it would matter if it was like on the graph and it was negative or not.
Like this one?
Yeah.
Yeah, it does really matter. This point is the most important point because this is how we know how much we move. Because it used to be at 0, 0. So you can tell that mostly all your basic graph, they all have 0, 0 as your starting point. And the transformation that you have here will move all this 0, 0 left, right, up, down.
Okay.
Next we have is reflections. So if you have a negative in front of your function, you will reflect this on the x-axis. For example, negative x squared, negative square of x. What happens when you reflect this on the x-axis is if you have a parabola, it will go downwards. This is the meaning of reflection on the x-axis. Like you flip it. If it's up, you flip it down. If it's down, you flip it up. You got what I'm saying?
Yep.
And if your negative is inside your x, this is a reflections on the y-axis. So every time when I talk inside, you have to parenthesize this. So if you have a negative that is inside your function, you reflect. Now the good news is if you have a parabola, if you reflect this on the y-axis, you still get back the parabola because parabola is a even function. So when you reflect on the y-axis, you still get back the same thing. But if you have a square root of x, this is square root of x, what happens when you reflect this on the y-axis? It goes to the other direction. So what is going on to reflections on the y-axis is if you have a left, you move to the right. If it's a right, you move to the left. So that is the meaning of. So another way is just thinking about if you fold your paper, the other side will be the reflections on the y. And if you go fold it up the other way around on the x-axis, that is how you reflect on the x-axis. Tough, yeah?
All right.
And you need to know all this transformation. The next transformation is called a non-rigid one, means that you have multiplied with a constant. So if you have a of f, a is been multiplied to the function of x, not add or subtract, it's been multiplied. This is what we call as a vertical stretch or vertical compress. Or sometimes your textbook use shrink. Compress and shrink is the same thing. How do we know it is a vertical stretch? Your a has to be greater than 1. For compress, your a is between 0 and 1. So what happened is that if you have like 2x squared or 3 square root of x, because this number that you multiply is greater than 1, you have to vertical stretch it. So what happens when you vertical stretch it? This is your parabola. So when you have the 2x squared, you vertical pull this, so this graph will get narrower. Okay. One way I will tell you, if you doesn't know what it looks like, is there is a graph, there is a website called Desmos Graphing. Just type Desmo in your Desmos. So you can figure out what it looks like. It used to be different. Graph. Maybe, yep, Desmo graph. So this is the one. So example is if you type x squared, this is the parabola x squared. So if you go click on the other one, if you want to type 2x squared, so you can figure out your graph is getting narrower. So look at your y-axis, look at your value. So this one used to be at 1, 1, right? No, 1 is here. So 1 is 1. So what happened is it's been doubled. You see the y value has been doubled.
Yep.
So all your y, in this case, when you have a 2x squared, your y value is been doubled. And when you have a 3x squared, your y value is been tripled. That's the meaning of that 3, the number in front. And if you have a fraction like half, now your graph, your y value is not double or triple, it's cut by half. So that's why your graph looks wider. So you can look at this. So this is x squared. So if you type 2, the blue line, if you look at the blue line, it's getting narrower. If you put 3, even narrower. If you put 4, so the higher the number you put, the graph is getting narrow. But that number has to be greater than 1. But if you put 0.9, the graph is getting a little bit wider. 0.8, more wider. 0.5, more wider. 0.1, even wider. 0.01, even wider. So you see that. So what happened in this case is if vertical stretch will mostly make your graph narrower. And for compress, when you have like a half of x squared or 1/3 of cube root of a square of x, this graph will get wider. Okay, so this is what happens when your A is outside. What happens if your A is inside? Then you completely switch this around. So vertical become horizontal, stretch become compress. This is when A is greater than 1. Horizontal stretch when A is between 0 and 1. So what happened is now your A here is inside. So if you have an inside like this, one of this is what we call as horizontal compress. So what happens when you have horizontal compress is you take something here and you try to horizontal compress. So you press all the way in. So your graph will get narrower. So for example, so it needs a parenthesis. So you find out that when I put 2 in here, your blue line, it's getting narrower, your graph. If I put 3, even narrower. Now, I just want to point out to you that last time, when you remember when I said 2 is double, 3 is triple, but when you put a horizontal compress with a parenthesis, you are actually doing more than that. So if you put 2 in here, you actually your x value is your y value is actually multiplied by 4 because 2 squared is give us 4. If you put 3, your y value is actually multiplied by 9. Okay, and then if you put half, you get wider. Okay, and actually the value is not half. Half of it is actually half square, so it's 0.25. So it's actually, so make sure that when you do this, this is what we call as horizontal stretch and horizontal compress. Again, stretch will make your graph narrow, and compress will make your graph wide. It has the same property, but but your value is changed. For example, will be 1/2 x squared or 1/3 x. So these are all the transformation that you have here. So what you do here is you will look at your graph on number 4. So we know this is a parabola, but can you tell me what happens to this graph? Do we move up, down, left, right?
I think down
How many?
by 4.
4. So when you move down 4, where should we put that number? Should we put it inside like this or outside like that?
Outside? Outside?
Yep. So your answer in this case will be x squared minus 4. Because it's been moving down 4. Now this one is very special. What kind of transformation can you tell me from a parabola to get into here?
I went to the left one time, and then I went, what is it? It moved up 3 times.
Not 3 times.
On your graph, it moved up once.
Yep. So on my graph, I don't know your graph, is move left 1 and up 1. So left 1, how do you say left 1? Is that minus or plus?
Plus.
Okay, so good. So this is x plus 1 squared. So this one is telling us you move left 1, and then you go up 1, right? Up 1 means you plus 1. But this graph is being reflected. Usually your graph is a happy face. Now this is a sad face. So what happens is it's been reflected by what?
By the x.
By the x-axis. So this one you have to put a negative in front. So this graph is actually negative x plus 1 squared. That means negative reflection to the x. Plus 1 means move to the left 1. And then plus 1 means you move up. Is that difficult?
No, I understand it now.
You want to try to do this one? This is an absolute value graph. Absolute value graph usually is a V shape. Can you tell me what transformation we have for 5A?
Let's see.
Do we move left, right, up, down?
So we move left 4 times.
So left 4 times means is absolute value of what? X.
X minus, what is it, 4?
Again, if you move left, remember last time when you moved
X
left.
plus 4. X plus 4.
Yep. But this is a V shape originally, but this V is going upside down now. So what kind of transformation will make him go upside down?
Reflection of the x.
And what you need to put?
So negative at the front of the.
Yep. That's your answer. How about this one?
So it moved down 6.
And
then it moved to the right.
For my graph, right what?
Like 3.
3. So how do you write move right 3?
What is it? Subtract 3.
Very good. Inside the absolute value. And then what else do you add on to move down 6?
Subtract 6.
Yep. Do we have any reflections on this one?
Nope.
So this is your answer. Yep. You okay there?
Yep, I'm okay now. I understand it.
Yep. So make sure you know. So you always look at this point. That's the point that tells you, because it used to be at 0, 0. So mostly all the graph here has a 0, 0 points, and moving left, right, up, down, it depends on where it moves that point. Same thing with this. It used to be at 0, 0. You okay?
Yep, I'm okay.
Yep. So this one, it used to be like this. Do you know what happens when you move it that way? This is special. Let's do this one. Let's do this one. So this is a square root of x. This is tough, actually. So can you tell me what transformation moved from 0, 0 to this point?
And move to the right 3 times and then down 4 times.
So can you tell me what is the move left to the right 3 times make him?
So inside of the square root, it'll be x minus 3.
And what makes then how?
And then outside of the square root, it'll be minus 4.
Very good. Now this is your graph. If you do this, your graph will look, sorry. If you do this, your graph will look something like this. No room. Like this. Okay. So it's right over here. But now if you look at your graph is going this way. It used to, if you put this, your graph is like this, it looks like that. So what makes him go this way?
Is it the reflection of the x-axis?
If you reflect this graph on the x-axis, it will only go like this. So if you want it to go this way, it actually have both reflection. Reflect on the x and reflect back on the y. So when you have a square root graph, if you reflect this on the x-axis, it's right here. If you reflect this on the y-axis, it is right here. If you reflect on both x and y-axis, you'll be going here. So you can tell that where the direction is. If a direction is going on the, like going up to the northwest, northeast is normal. But if this go to the other direction, it's a reflection of the y. If we go down, reflection of x. If we go down and the opposite direction, it's both x and y. So this graph actually has what? Both reflection on what? X and y. So how do we write this? Is reflection of x, you just put a negative in front here, right? And reflection of y, a lot of students just put an oh, as what David says, if it's reflection of y, you put a negative inside the square root. So a lot of students just put this way and you get it wrong. The reason why you get it wrong is because you need a parenthesis here. So the reason, because when you do reflections, you have to have parenthesize the whole thing. That means multiplication. So so if you don't parenthesize this, they will mark you wrong. You okay there, Sinu?
Yep.
Okay. So make sure this is a bit tricky here. So make sure you got that. All right. The parenthesis is a tricky one. 17 and 19. So this one is the same thing. You just need to give me the function that is shifted 6 units to the left, 7 units down, and then reflect on the y-axis in that order. So can you tell me what happens when you shifted 6 units to the left?
You're adding 6.
So it's x plus 6 to the power of 3, right?
Yep.
And then how do you do 7 units down?
Subtract 7.
Subtract 7. And then you reflect this to the y-axis. When you reflect, you put a negative, right? In or outside?
In.
Inside. So you just put a negative inside here. I think now this one, you do not need to put parentheses on it because it's say in that order. So you do not need to put parentheses on that. But if you do not follow the order, then you have to parenthesize like what we just did on the previous question.
Okay.
Okay. This one also in this order. square of x is shifted 3 units down. So how do we write 3 units down for this case?
Outside of the square root, it would be subtract 3.
And then it is reflected on both x and y axis.
So it'd be negative parentheses.
You don't need parentheses here because it's only have one variable. So you just put negative here. This is reflection on the y-axis. And how do we figure out reflection on the x-axis? Because it's both. It's very similar to the one that we just did just now here. So remember this one. This means you reflect both x and y. So we put negative in where?
On the outside of the square
both
root?
in and out. Yep. So in this case, you have the both in and out. And the reason why you do not need parentheses in this case is because this one only have x involved. So if you have x, if you move left or right, then you need parenthesize on this one. You okay?
Yeah, okay. This makes more sense.
Oh, this one is wrong. Let me see. Oh, I think you need a you need parentheses on, sorry, you need parentheses on this one now. Yep, this is the, because you reflect the whole thing on the x-axis. Yep. Yep, you need parenthesize on this because it reflects. Do not worry much about 17, 18, 19 because that is the wrong way to do it. Because if you are following exactly this transformation, then this is what you do. But usually there is order here. So how do we follow orders is the orders is using orders of operation. PEMDAS. So anytime when you guys, when you draw your graph, you have transformation, you follow PEMDAS, means inside the parentheses, and then exponents, multiply, divide, and then addition, subtraction. So this 3 question did not follow the orders, so that's why it is weird. But the rest of it, you have to follow the orders of operation. You okay there, Sinu?
Yep. This makes more sense now.
Yeah. So I'm going to start a little bit on 2.6, which is going to be a little bit different from what you did. So we call combinations functions, composite functions. So when you have a combination functions, so for combination functions, we perform what we call as adding, subtracting, multiply, and divide. So when you add 2 functions, you just take the 2 functions and add it up. When you subtract 2 functions, you subtract the 2 functions up. But watch out for when you have subtract, because you have to distribute the negative to g of x. What do I mean by that is, like here, we got f is this, f of x is this, and g of x is this function. So when you subtract, see, you have to distribute the negative. This is what a lot of students did not do. So they just simply write -2 minus x without the parentheses. They forgot to distribute and everything's going to be wrong. So watch out when you find the difference of 2 functions. The g of x has to be in parentheses and you have to distribute it. Product, usually you multiply, and multiply means is foiling. So you just FOIL it out. Divide, you just divide them. But again, when you have divide this, you cannot cancel the 2 and you cannot cancel the x. The reason why is, in order for you to cancel it out, you have to cancel the common factor. So you actually have to factor it. But this 2x minus 5, you cannot factor. 2 minus x cannot be factored. So if you cannot factor it, you cannot cancel it. You just need to watch out for the domain in this case. For this deep, everything here is all real numbers. The reason why they are all real numbers is because they are all polynomials. The only thing that is not all real numbers is when you divide, because we cannot have a denominator become 0. So in this case, your domain in this case is all real numbers except 2. That means you cannot have 2 here. That will make him 0 in this case. When this is for when you have 2 nice functions like this. But what happens if one of the function is square root and one is a function is a fraction? When you add, you just add them like this, add those 2 up. When you subtract this. Do not simplify this because it will take you one page long to just simplify this. So leave your answer as what it is here. Then when you multiply this. When you multiply these two, this is, don't forget this x squared minus 4 is over 1. So you multiply them straight across. So you get x squared times square of x squared minus 4 over by x squared plus 1. Now, a lot of students think the square of x squared minus 4 is x minus 2. It is not x minus 2, okay? The reason why it's not x minus 2 is because although these two are perfect square, you know, x squared is x, 4 is 2, because of the minus sign, you cannot simplify it to become x minus 2. So do not do that, okay? The last thing we talk about here is division. So when you divide this over that. So when you divide this, you can always change the division over to multiplication, but your denominator, you have to flip it, okay? So when you flip it, this will become x squared plus 1 over x squared. So don't forget, when you divide, you have to multiply and flip-flop. And then you multiply them straight across. So this will be x squared plus 1 over by square of x minus 4 equals to x squared. So finding the domain for this is the difficult part. Okay, so I'm going to teach you how to find the domain of something weird like this. So if you have x squared plus 1, x squared minus 4 over by x squared, how do you figure out your domain here? Okay, now this does not play an important role. I can cross that one out. The reason why is because this is a polynomial. Polynomial, the domain is all real numbers, so that doesn't play an important role. But this and this plays an important role. Now we know that we cannot have this equals to 0. So that means that your x in this case cannot be 0, because if this is 0, your denominator is 0, it'll be undefined. And the other thing that the reason why I'm circling the square root is because square root, you cannot be negative. Because square of a negative number is complex. So what you do is you try to figure out what number that you plug in here for x will make him negative. Will make him positive, sorry, will make him positive or 0. So do you know what happens? So we drew the number line here. So always I teach my students. 0. Do you know what happens when you plug 0 in here? Does that make him negative, positive, or 0?
0.
0 squared minus 4. What is 0 squared minus 4?
-4.
So this is no good. Because if you have negative number inside the square root, it's complex. How about 1?
-3.
Also no good. 2?
0.
0 is good. 3?
It'd be 2.
9. 9 minus 4 is
5.
right. 9 minus 4 is 5. So it's positive, right?
Yep.
So as long as it's 0 and positive, it's good. If you got negative, and you find out 4, 5, 6, they're all good. Because that will make him positive. Now let's take a look at -1. What happens when you plug -1 in here?
It'd be -3.
Which is no good. How about -2?
It'd be 0.
How about -3?
It'd be 5.
Which is good. As long as the number is 0 or positive, it's good. -4. So this is all good, right?
Yep.
And then on top, because of this, you cannot have 0. Because your denominator is undefined. So what is your domain? Your domain is the one that from a checkpoint. So your domain in this case is from all these numbers from negative to negative all the way here, and then this. So all the one with the checkpoint means it's good. So your domain in this case is -infinity to -2, 2 to infinity. And I can show you a shortcut how we figure this one out is how we get 2 here, negative and positive, it came from square root of 4. So that's why you get 2. So can you figure out what happens to the domain if I ask you for x squared minus 9? What would be your domain would be?
It would be, the domain would be negative infinity, -3.
And make sure you put a bracket on it.
Yep. And then 3 to infinity.
Yep, and also bracket on that one. So it's very easy. So now you figure out, you do not need to draw this number line anymore. So if this number, usually in your homework and your test, these numbers are perfect squares. So I don't give you weird number like 5 or 6 or 7. So you can figure out very easily the domain now. You okay there?
Yep.
And then the next thing we talk about here is composition function. The composition function is the dot. Okay, and a lot of students get confused between the dot and the period here. So when you see a period like this is product multiply. You FOIL it out. But when you have a dot, means you have to do the composition function. So what is a composition function? A composition function is telling us that which function do we do first. So if you have f dot g of x, you will do the g of x first. You put the g of x into the f of x. So it's like substitution. Okay. So for example, is if f of x in this case, let's say is 2x minus 5. And g of x in this case, let's say is 2 minus x. So if I want you to find f dot g of x, what do I do here is I will take g of x, which is all this, and plug it into your f of x, substitute. So you will get 2 parentheses minus 5, and this x will be replaced by 2 minus x. So this is the meaning of f dot g of x, and then you distribute and you simplify this. But if you got g dot f of x, this means that you have to take f of x, put it back into the g of x. So the other way around. So what you do is, if you have g dot f of x, always do the last one first. A lot of students get confused. So you take the f of x first, and you plug it into the g of x. So your answer in this case is 2 minus, then you put 2x minus 5. Then you simplify this. Distribute your negative and so on. So this is the meaning of f dot g and g dot f. And yes, you can do f dot f. What is mean by f dot f is you take f of x and you plug it back into f of x. So this is f of x, and you plug it, replug it back into itself. So it's 2 times minus 5, and this x is 2x minus 5. You got what I'm saying, Suno?
Yep.
So so if I give you a lot, f dot g dot f of x. So if you have, this is called triple composition, means you have to do, you take the very end, which is f of x first, plug it into the g of x, and then plug it back into the f of x. You know what I'm trying to say here? So the more you do, the more you have, I mean, the more dots you have, the more, and you always start at the end and you read backwards to the right to left here. So how we do f dot g dot f is we do f of x first, which is 2x minus 5, and plug it into the g of x. So we got 2 minus 2x minus 5. Let's do, this is this piece. So we do this piece first. So you will get 2 minus 2x plus 5, which will be 7 minus 2x. And then what you need to do next is you take this and you plug it back into your f again. So you will get 2 parentheses minus 5. And this x will be replaced by 7 minus 2x. And then you figure, and whatever you do this, you distribute and so on, that's your answer. Sinu, are you okay?
It's a lot of steps, but
Oh, yes. So mostly what I'm telling you here is if you, the more dots I give it to you, the more you will do. But usually I won't give you this kind. I will give you either f.g, g.f, f.f, and g.g. That means you only plug it one time.
yeah. I
won't give you all this crazy, this one. Maybe in calculus you'll see this, but in this class you will just see this basic stuff. Okay. I would recommend you to go through my notes because that is the notes is posted in D2L. This is how we do it. And I also post some videos. I did teach this one. So you have actually three homework due tonight, right? 2, 3, 2, 4, 2, 5. And then you got 2 homework due on next Wednesday, which is 2, 6, and 2, 7. So yep, you have to do a bit more work here, and the class is getting a little bit more difficult. So just want to point out to you. And then what 2-7 is the last section of chapter 2, and then we will start chapter 3 after that. Your test, your first test is in April, I think next 2, I think April 7 or April something. It's like first week of April or second week of April. It does consist of chapter 2 and chapter 3. So so make sure you understand this. This is quite important here. All right, that's